The broadcast is now starting. All attendees are in listen-only mode.
Hello. Thank you for joining us for the CDN webinar focusing on the latest improvements and new features of Alias 2012 from Autodesk. My name is Eric Galina, and I'm the editor of CDN. Autodesk will shortly present their webinar focusing on automotive design workflows with particular emphasis on the new panel group tool. Paul Deyo, Senior Principal User Experience Designer at Autodesk, is presenting. Paul has over 28 years experience in transportation and industrial design and has been involved in scanning, modeling, and visualization. He works with customers to understand their requirements and translates them into design tools. Over the course of the webinar, Paul will also be presenting 3 poll questions for you to answer, so please do participate. Paul will wrap up with a dedicated questions and answers session at the end of the webinar. Before I pass over to him, I would like to remind all of you in attendance to draft some questions which Paul will answer in the Q&A session following his presentation. Please ask these questions by typing them into the box in the lower right-hand side of your screen. If you should happen to experience any technical issues during this session, please also type these into the Q&A box, and our team will do their best to sort these out for you. If you're using a PC, be sure to check that the audio is not in mute mode. We hope you'll find this webinar stimulating and informative. I'll now hand it over to Paul so he can begin the presentation. Thank you. Paul?
Thanks, Eric. Well, welcome everyone. Thanks for attending this webinar. It's our hope that today we can show you some simple workflows on a concept model that'll help you understand what kind of efficiencies we've tried to bring to the new 2012 release. Before we go there, I'd like to do a poll, and we're doing this to learn more about our audience. And if we could start with the first poll question, that would be great. So we know our customers have been using various releases, and we also like to know how many of our customers haven't used Alias, so I can be a little bit more specific about features as I go through this. Okay, thanks very much. Appreciate that. So let's proceed. I did want to mention, first of all, that we can't tell you about all the features in 2012 in today's webinar. I'm going to concentrate on some of the items that are more focused on efficiency and greater control. But you will find that we have a wiki help, and in that wiki help you can actually get lots and lots of information, including new What's New videos by our friend Kerry Kingston. I'm going to just go over to Alias right now and show you where you can get to that. If you go to the Help menu, underneath Alias Wiki Help, that's going to bring you up to this wiki page, and you'll see here What's New in Alias 2012. And there's a whole series of videos that goes into greater detail than I will even today. And the other good thing about the wiki is it's a place where people can participate in a community. Whether you're a new user or whether you're an old-time user, we appreciate your adding comments and workflows to this wiki page. So it's for everyone's benefit. I think it can be a very useful resource for everyone. Now let's take a look at what I've got here. Before I start the actual demonstration, I've got this concept model that a lot of the demos are based on, but I'm showing it in our geometric environment mode. So this gives you the ability to put a car into context when you're doing a design review, and then easily slip back out to be able to do diagnostic evaluation of the model even during a design review. So you can switch back and forth. And I also wanted to talk a little bit about data organization. So, you know, it's always fun to do the sexy demos, but actually the basis upon which people can become efficient in the way they work is based on how they use data organization. So we've done a few things in 2012. The most important one is how we've changed the object lister. So if you're familiar with the object lister, you may have been more familiar with it in this mode. So if I say go, it's a floating window, which is still available. But what we've done in order to try and save screen space, you'll see underneath Windows, Object Lister, in the option box, an option for embedding it. So we're looking for ways in which we can save screen space and yet still give you access to all the tools that you need or data organization. So this is something we introduced in 2012. There's a couple of modes for it. This little black icon down here is called the Auto Hide button. When I select that and my cursor hovers over the tab, the object lister comes out immediately. When my cursor goes back into the view, it embeds itself back into the window. So really useful for like design reviews where you're going to make some selections and then subsequently you want to be able to have that out of your field of view. The other mode is when you flip this, then you can actually make it a persistent selection. So now you're actually doing work. Then the object lister is something you want to leave there and keep persistent. You can modify its position here. You can change the length of it. Here, let's show all the data that I've got in this. Notice I'm not using a layer bar across the top. That's because I find it more efficient to use the object lister to be able to access and organize all the data in one view instead of trying to do it across the linear layer bar. So I'm going to switch my visualization mode, take it out of the geometric environment. There we go. And now I'm showing all of my layers. One thing I've been using is categories. So I've got a category editor here. You'll notice that when now I can take and I'm selecting this Chrome, and then I'm just going to drag and drop it into a category. And a category is really a set of layers. And you'll notice how the number incremented here. And I've got a completed model, but for each of my demonstrations today, I've created a separate category in order to have all the data that I want in one place. And you'll notice as I move between the different categories, it only displays the layers that are a part of that category. So it's a good way to organize things for ease of access and to remove a lot of overhead in terms of what visually you see inside the object lister. There's some other simple things inside here, such as being able to select and reorganize your menu by using the center mouse button, just to keep the organization of the layers so that it makes sense to you. There's also the ability to do things like select and then delete. In this case, I'm going to delete this grill setup. I don't need it anymore, so let's delete that. I can also insert. I can also modify my object groupings using the right-hand context menu. So that's all about data organization, drag and drop, and just making things work the way that they should work. Now let's take a look at something here that's really at the heart of a lot of the modeling capabilities inside of Studio. I'm going to just bring up a portion of our model and talk a bit about the transform CV. So one of the things that we recognized by looking at the statistics from our users is that direct modeling, modifying a model by working with the control vertices, is a workflow that many people appreciate. So what we tried to do in 2012 was to make that more efficient, make it so that there's less repetitive tasks. And one of the ways we did that is by modifying the Transform CV tool. If you remember, this is a tool down in the lower right-hand corner of the control window. And that in the past meant that as I moved from my model over to the Make Modifications, I was constantly moving back and forth. So in order to maintain your focus in your modeling space, we've created the hotspot. So this hotspot are all the transformations and modes available wherever your cursor is at by just pressing down on the spacebar. So it means that your attention doesn't move off of the model in order to make changes. We've also, in addition to the transforms, which include move, we've added rotate, scale, non-proportional scale, and I'll go into a little bit more detail on proportional modification because that's a real cool feature, as well as the set pivot. So everything you need in order to be able to do modeling is in one place. At the center, either I'm selecting CVs or I'm selecting a hull, and then you, in the move mode, you've got all the regular transformation modes. In addition, there's a new view-based move here as well. So here I'm going to select this hull, and I can immediately go in and modify the pivot point, and then I could do a rotation, something that in the past you would have had to leave the transform tool, but now it's all in one place. Another one of the efficiencies that we want to point out here is the fact that when you're modeling, you often need to change the amount of controls in a surface in order to be able to give it more shape. So for what is a problem, especially if you're zoomed in close, is which is the U direction and which is the V direction. And we've made that more discernible in a couple of ways. First, if you go into Preferences, Interface, User Colors, you'll see that underneath Inactive and Active Modeling Colors, there's both a color for U and a color for V. So what that does is that when you're looking at the model and when you've made selections, you can discern which is the U direction and which is the V direction. And we've supported that further by, if you go into Object Display Draw Style, you'll also see that their V-hulls can be made into a dotted line. So these are cues that make it possible for you to make selections and changes more efficiently without having to guess. So in the past you would have had to guess U or V, and as one person told me, they're wrong about 80% of the time. So now you'll also notice I want to make this degree 5 along the U direction, so there's a drop down now. I don't have to type in anymore. All I have to do is select degree 5 here, make modifications. You'll see that the deviation is always displayed here on the prompt line, and then I'll just go ahead and accept that. So now I want to demonstrate a little bit more in detail this proportional modification. So again, I hold down the spacebar in order to bring myself back to the hotspot and go to the proportional modification. When I did that, notice that a fall-off slider came up here in the corner. What I'm going to do is just to make it a little easier to see how fall-off works, I'm just going to take a curve, and I'm going to make it degree 6, and I'll accept that. And now I'm going to use the proportional modification, and I'm going to select this one. The proportional modification is all about applying the transform to subsequent controls along a certain rate of change. So what I'm going to do is have a primary CV, then I've got a manipulator here, and the manipulator allows me to add controls to it. I can either hit the arrow, which adds or subtracts controls, or I can just use Shift and box select. Now that I've got this set at 0 and my transform mode is move, I'm going to pull this up, and you'll see that all the controls move the same amount. Now, that can be useful sometimes when you're using the slide command inside proportional modification. But to make it clearer what the proportional modification is capable of, I'm going to slide this over to 1 and now move it in the Z direction. And if you look at the hull, you see that subsequent controls are moved less and less. And so as this slider moves to the right, you get more and more fall off, making for a smooth transition along all these controls. So the reason that you'd want to be able to use this is to apply minute amounts of changes to the primary CV and have that fall off across the rest of it. Let's take a look now if we do the same thing on this surface. So now I'm going to use the transform, and we'll use this surface here, and I pick a primary CV, and I'm going to select the extents by holding the Shift key down, and then I'm going to make modifications by moving this in the Y. And you can see that's just getting a bulge in this area because I've got the U sent to a very high number. As I pull this down and put it around 1, now as I modify it, you can see how that is applied to the surface, and you get that bulge through there. Another cool thing about this is that if I then, like, let's say this was the body side and we were going to extend this across the wheel wells, I'm going to do an extend on the two ends, just as an example here. So now we've got this extended into 3 surfaces, and I'm going to pick all these and then go into the Transform CV. Now you'll notice that as I select this control, I can actually go and move across multiple surfaces. So as long as there's a positional continuity between the surfaces, it does allow me to make proportional modifications across multiple surfaces. This can be useful even when you're doing things like building a shoulder line along the top and you use something like the Drafts tool. You can continue to modify the line of controls along the top just by checking and selecting across these boundaries. Now you'll notice right now it's not maintaining continuity through here. So let me show you what you can do in order to get continuity and maintain that continuity. I'm going to use the align between this, and between this surface here and this surface here. So now I've got a curvature alignment between these two, and I'm going to then again go in, pick all the surfaces, and again do a proportional modification. And you'll notice that as I do this and extend the range, because the Align tool allows you to make modifications to controls, as I pull this thing out, it's actually maintaining curvature continuity across the boundaries. So proportional modification is a way to be able to create sweet looking surfaces, and now because it allows you to do it with multiple surfaces, you can do it amongst any set of surfaces that have the same number of U or V controls at the boundaries. Okay, let's see. Let's go into another area. In this case, we're going to talk about using the multi-surface draft tool. So again, I go back to the object lister, and let's pick the grill. Okay, and here's a little detail area. So I put this grill together as a way in which to demonstrate some new capabilities. Again, we were talking about the use of the categories. Here I'm going to just turn on the grill curves, and those curves are going to come on here as soon as I turn on the model. There we go. So there's a set of curves in which I used to develop this layout. And the MS Draft tool, and I'm just going to turn off the final hood and bumpers and chrome, just concentrate on these curves. So in the past, the multi-surface draft tool couldn't accept curves as input, so we did a lot of things to change that. So I'm going to bring up the multi-surface draft, and you'll notice that there's a pick mask down here, so that I can easily select a whole group of curves. In this case, I'm going to give it this vector as input and tell it to build those draft surfaces based on that vector. You know, if we look at the detail in the corner, everything is clean. All the edges line up. I'm just going to put it into multi-surface color so that we can distinguish those a little better. But imagine if we're going to put some draft in there. So now let's put the draft on those at -2. And then you're going to see that naturally, as the surfaces respond to the draft conditions, the corners intersect. We want to be able to trim those out cleanly. So there's an option now inside the multi-surface draft that allows you to intersect those flanges. And now all of those will be trimmed out to this outside edge. So multi-surface draft now gives you the opportunity to have surface curve input as well as curves on surface and surface patch edges. You can get through easily selecting based on using your pick mask here. So we'll just undo that one for now, and instead let's bring the surface that I actually built from. So now I'm going to put the grill surface on. I'll leave the curves on for a second because I want to be able to project onto that. So I'll do a projection on this surface along that vector and use these curves as input. So now we have a series of curves on surfaces. And just for the sake of understanding how the pick mask works, let's go in, and this time we're going to build draft surfaces. We'll do them this time in an X vector direction. And since this is now selected for curve on surface, I'm just going to put a box selection around this whole thing. And because it knows that it's not using the curves, it's going to hit those curves on surface, and it's built a whole series of boxes that have been intersected, just like we showed on the curves. Now the tough spot here is when you want to be able to cut those off at a certain depth. So I'm going to turn the curves off here because I don't need those, they just get in the way. And I want to talk a little bit about some improvements to the intersection capabilities and to the trimming. So first, let's do an offset of this front surface. I'm just going to offset that 5 millimeters. I think it might be 2 millimeters. So now I've got an offset surface. It's selected now because it was the output from the offset tool. Now I want to do an intersection. So in the past, I would have had to select each individual surface in order to do an intersection. Instead, what you can do now is just pick all those surfaces, and immediately creates the curves on surface based on an intersection of that with all of those pieces. Now the next part I want to show you is a time saver when it comes to trimming. So if we pick these surfaces here that we've extended back, we've got 153. I don't think I've gotten them all. Let's make sure we've selected them all. (163) surfaces. In the past, trying to get those things to trim would be a time-consuming affair. So now, when you're doing trimming, you can use a view base in order to be able to select the trim region area. Excuse me. So now that I've selected what I want to trim, now it's as easy as just putting a box here to select that I want to be trimmed away. So I'm going to discard those. And now we've trimmed all of those boxes with a single selection. So that's based on a view. You can always back up from that if you need to in order to reset and do it again. But just the speed with which we're able to do an operation that really could take a lot of coffee now can be done much faster. Here I'm going to discard this area, and then we'll light it up. So something that may have taken really hours before is only really a couple of minutes using the new trim capabilities, intersect, and MS Draft. So I wanted to take a second now in order to ask another poll question. So can we post that now and have the audience give us some input? Diana, do we have that poll? Here we go. How long have you been using Alias? I know some people out there have probably been using it for 20 years. Okay, thank you very much for responding to that poll. What we're going to look at now is an addition to our filleting capabilities. Here's a deck, and what I want to show here is I'm going to turn on this one, and then let's get back to where we can see the surface boundaries. So sometimes the user has a need to be able to build a transition relative to another part. So in this case, we've got a deck, and then we've got the shoulder between this rear quarter. So how do I get a transition to happen so it has some sort of relationship with the deck? The conventional way to do it would be to build a surface fillet. So let's turn on the surface fillet here. We're going to pick this wall and these surfaces and have it build between those two. So now we've got, and let's just change the color a little bit so we can distinguish it. So now we've got something that doesn't quite correspond to the way that the deck edge is. So one way to change that would be to change it into a variable fillet. And now I can take and try and keep, there's 40 seams about right here. Let's put another one about there and reduce it from 40 to 35, and then we'll put another one down at the end here and make it 35. Take a look and see how that looks. So it's better, but the problem here is it's difficult to build the transition back from the target. So variable, it's possible to do it, but there's a lot of trial and error and experimentation. Let me show you another method that you can use with this new tool. It's called Symmetric fillet. So same setup, but this time I'm going to build my tangent line. I'm going to drive the design from the tangent line. So let's duplicate this surface edge right here. So now we've got a curve. Just temporarily I'm going to turn off the deck so that we can see this from the side view. Here's the intersection of where that deck was with the inner quarter. And I'm just going to make some modifications to where I think that should go. So here I am moving this down. There's my tangent line. Of course, I'm using the transform CV tools in order to be able to use project normal. And now let's pick the rest of these. Using the shift, I'm going to switch. Oops, I missed a spot right here. Pull that back up. There we go. And now let's pick these down here. Remove those. Yeah. Let's add this. Wobble here. There we go. So I'm going to get it bigger at the bottom, and now in this transition area I'm just going to switch and move this down. There we go. So now let's use this as the basis upon which we want to have a tangent line here. I'll use the project onto this surface and using that curve. And there we go. So that's our tangent line. Of course, we can always modify that tangent line by modifying the curve, but we'll just take that out of the picture for a second. Let's bring back our deck lid in order to just illustrate how this is going to work. So now I've got the line I want to use as the driving transition point, and I'm going to use the symmetric fillet. Symmetric fillet wants to use the tangent line. Accept that. And then what's the opposite wall? And the reason that it's called the symmetric fillet is because it takes that tangent line and drives it over onto the other side. So now the transition has been designed back from the tangent point instead of trying to guess where that tangent point should be using variable. Of course, I can make any modifications I need to the input curves to improve the look of the transition. I'm going to make some changes here at the start. Let's make it extend. And by doing so, that's going to allow me to trim this side. And we've extended out, and on this end we could do an extend as well. So that just allows us to push that a little bit farther in order to make sure we get a trim happening there. And we can always make modifications to the tangent line. One other thing that we've included here is something called modify range. What modify range is doing, and this is something that we're looking to, just like we put in the curve fit in a line, allow you to modify the range that you want a fillet to be built. And so what this does is now modify, take this from the bottom, in case there are areas where you want to make transitions. And if I uncheck this, it's going to go back to its previous extended trim. One more point about the symmetric fillet control is that it's using the form factor just like the regular surface fillet is. And what the form factor does is allow you to design the amount of peak in your fillet. So the farther you move this thing to the left, the sharper that fillet is going to become. Now the CVs have moved closer. You can see from the highlight line that it's gotten sharper. And then as I move it to the right over here, it's going to get flatter. Whatever you choose as a form factor, you can then use as a value in all of your surface, any applications of fillet tools, because they all provide the form factor as an option. Okay, now let's take a look at something that we call panel gap. And I'm going to switch over for a second to my PowerPoint slides because I want to show you, and we can review here for a second. Talked about the object lister, how we're saving space by embedding it in the side, adding additional context-based menus inside there. We talked about the efficiencies of using the transform controls tool, a hotspot, so you don't have to change your focus and you can reduce the amount of mouse kilometers you might have. We've expanded the number of transform modes, including the view, and given you better feedback, hopefully, in terms of what's U and B. Talked about the multi-surface draft, the fact that you have curve inputs, you can intersect flanges, and then the intersection and trim changes that allows for selection and much faster trimming than you've experienced in the past. And then the symmetric fillet, which we just finished. So now I want to talk about panel gap, because panel gap is focusing expressly on a task that automotive designers need to deal with. And this includes both concept modelers as well as technical surfacing people. If you look over here in this image, panel gaps is all about being able to create the correct gap between surfaces. Sometimes it's an even gap, but other times it has to be a variable gap. And what we're trying to do is reduce the overhead in terms of being able to lay those out quickly on the model and then subsequently committing to them, and then still having the construction history capability of making changes. So we've incorporated 4 different kinds of capabilities within the panel gap based on which options you change. The conventional one is just 2 flanges side by side, but it also has something called a closeout, and I'll demonstrate how that can be useful. One really interesting and useful feature is the fact that the surfaces do not have to be in the same plane. They can be offset from each other. So in a door panel, you can put an offset between the back of the front door and the rear quarter of the rear door and still maintain the gap condition between them. You can do a hem flange on one and a flange on the other, or you can have 2 hem flanges. So there's a lot of flexibility in terms of how you use it. Let's take a look at the details on how you interact with it. Okay, let's take a look. I'm going to go to one of my categories here for the panel gaps on a door. So this is a pretty typical case where you've got a body side and you want to be able to quickly define and then create a gap in between the door surfaces. So let's start by doing a project on these 3 surfaces using those curves as input. make sure we got the right direction here. And we want to project in the Y direction. There we go. Those curves. There we go. Now, if this was, so these are 3 tangent continuous surfaces. And the difference, or the thing to note when I'm doing this part of the demonstration, is that they're all a single curve on surface as opposed to having separate surfaces. I'll demonstrate that as well. But let's start by doing a panel gap on this door opening. So first it has chain select. So it's going to be easy to be able to select this curve on surface. And now there are a couple of options here. Which direction do you want the gap to be? This little arrow is going to indicate which direction you want the gap. Right now, for visualization purposes, let's put a pretty good sized gap there, 5, and radii of 5 on both the primary and secondary. So we'll go ahead and build that. And then I'll show you how you can make modifications. So now we've got a gap along with 2 flanges, and probably a good way to take a look at this, I'll just put some cross sections in the Z direction, and then put that away. And now let's just turn off the model for a second. And with that being the case, let's zoom up. So now we can see that there's a very small flange. We want a bigger flange than that, just so that we can see it more easily. And we'll do a rebuild. And since we do have flanges on there, and we're going to make them larger, let's now also put on this closeout flange and do a build. And what that closeout flange does for you is a couple of things. The first is that it can be used more easily for visualization. And I'll show you how you can easily select it. So now we've got these 11mm flanges being built. I'll toggle the model off just to make it a little easier to see. So now the cross-section showing our gap of 5mm here. I'll show you the evaluation capabilities in the next demo that allows you to confirm that you have the correct gap in between them. But now I've got the closeout back in here. Now let me show you how you can easily access that. I'm going to go over into the object lister, show by object. There's my panel gap. And now you'll see that the grouping of the panel gap is such that you can easily select a portion of it, in this case the closeout, or you could select the primary flanges and primary fillets. The reason for this is so that you can apply shaders easily. You know, it's not always, I'm just going to apply a black shader there. So now in terms of visualization, maybe not glossy, that's not that pretty really. There we go. So in terms of doing a visualization, how quick is it to just use the panel gap, add the closeout, and be able to select it and put a blackout on it. This is a pretty significant sized gap for a door, but I think it illustrates the point easily enough. You also may want to use those closeouts when you're doing milling, just to keep the cutter on the clay mill from descending past your model. So it's a nice little way to address that. I can also show you something that's pretty neat here, and that's the fact that I'm going to bring back the model so we can see that a little bit more clearly. So there are cases, like in, let's say for overslam conditions, where you want to be able to modify the gap. Right now we have an equal gap around the entire object of 5mm. This is really cool because here what I'm going to do is select and position, and I don't want to do a primary vector, I want to do a gap. So I'm going to switch that, and instead, there we go. So at this point, it's 5mm. That's good. Let me put another one down here, but at this point, just for the sake of making it obvious, let's make it 15. I know it's kind of ridiculous, but let's put 15. There we go. And now we'll put another one down at this end, and it'll come on as 15. And then I'll put one more here, and we'll put the depth here as 5. So we'll have 5 millimeter gaps here on the side, and then a 15 millimeter gap down at the bottom. Just going to turn the closeout off on this one so we can see through here. So obviously on a door panel you aren't necessarily looking for a 15 millimeter gap down at the bottom, but consider cases like door overslams or where you need to make a variation in the gap in order to be able to keep a perceived quality. So now you can see that I've gone from a 5 millimeter gap on the sides to a 15 millimeter gap along the bottom. So you have the option of being able to do variable gaps and variable draft on the flanges for both the primary and secondary walls independently. Now let's take a look at one more example here on the panel gap. And I'm going to switch over to a different example. This is going to be on a hood. And we'll delete those surfaces. And take a look at this hood here. I'm going to turn those sections off for right now, so I just do a clear on the global sections. And what I want to point out here, this is pretty important, is that there's a tangent break between these two parts of the surface. And it gives, the panel gap still allows you to build across a condition like that. Let's put the cross sections on again, just some X cross sections. And now when we use the panel gap, we'll use it with a gap distance of 3 and a primary radius of 3 and a secondary radius of 3. So now I'm going to take this wall. This could be multiple walls as well. It's going to be building on this side, flanges will be down, but I'm going to say adjacent surfaces and pick this surface here, could be multiple surfaces, and then do a build on this. So now you can see here we've actually created, I'm going to toggle the model just to make it a little clearer. Now I've made it so I've got a downstanding flange on the secondary side and a hem flange over on the hood side. A neat thing to be able to do here, and I'm going to demonstrate the shingling capability, because we have construction history between the panel gap, and if we make any modifications here, we turn the model back on, and then I'm going to pick this surface, and using my transform CV hotspot, I'm going to pick the hull, and I'm going to move it in XYZ. I'm going to select this hull right here. Now there's construction history inside there. What I'm going to do is come back and detail this a bit more by putting in a step size, and we'll just make it a fairly big shingle across here. But now we're going to just say, let's move that up 3 millimeters. And you'll see that the panel gap actually continues to update, even though I've made a modification to the offset here. Let's take a look. Now you'll see that I've moved the hood, still maintaining a 2 millimeter gap or a 3 millimeter gap in between there. Let's just do an undo here so you can see the previous condition. 2 millimeter gap or 3 millimeter gap, sorry. And then let's redo it. So putting the panel gaps in position means you can continue your design process, and yet you still put in a fairly sophisticated set of surfaces that maintain a gap condition between them. We're kind of running out of time, so I won't get into the variable flanges on them. But let me just show you one more thing. If I go back inside here, you have a couple of capabilities here. Again, we put in the ability to modify the location, because even in the cases where you're building panel gaps, there are going to be areas where you're going to want to transition into another different kind of a flange. So this allows you to control that. And then if you turn that off and you put it back to its original condition, I just want to show you how to do the evaluation, and then we'll see what kind of questions you might have. So if I put evaluation on, and ask it to check. I've done 50 checks here, and you can see that the deviation in that gap ranges very, very small. Okay, let's go back and just, for the sake of beauty, go back to the completed model. We'll get rid of that surface and take ourselves back to where we started from. I'm going to turn off those cross sections. And then bring back and the bumpers and the chrome. There we go. Okay, I think we've completed our, I think we may have one more poll question, and then we can take the Q&A. Fantastic. Great. Thank you for responding to that. I think that we're to the point now where we can have questions and answers. So, Eric, did you want to lead us in that?
Yes, certainly, Paul. There's a few questions that have come in, one of which I believe you've already answered, which is how do you share the hotspot? And I think you said that was brought about by holding down the space bar. Is that correct?
That's right, yeah. I'll just take it back real quick and we'll take a look at that. So whenever you're in the transform, I should mention too that if you have specific instances of a transform, for instance, I've put several on the shelf here. This first one is set up for a move. This one is set up for the proportional modification. And then you can always bring that control up by hitting the space bar.
Okay, well, thanks for answering that and clarifying that. There's another question that I'll answer myself. David has asked, will we be able to download this webinar later? Yes, fear not, David. All of this will be on Car Design News later, so you can view it, and indeed all of your colleagues can who are unable to attend today. So another question to you then, Paul. Is there a way to multi-surface draft to a certain length and keep all the extruded edges at the same alignment?
Not sure. Try that question one more time. I'm not sure I understand.
All right. He's asked, is there a way to multi-surface draft to a certain length and keep the extruded edges at the same alignment?
Well, we could take a quick look at that. Let's see if we can answer that question with an example. I'm going to switch over from the geometric environment and bring back my object lister. And we'll take the case of this grill. We'll just use the curves. I'm going to turn off the rest of the glitter and instead just go to the curve example there. So as I create the multi-surface draft, let's bring it up here. So this is set for curves, and I guess in order to answer that question, I'm going to need a surface that has multiple pieces, so I can do that. Let's bring this back, and we'll take this outside edge. So here's an outside edge. In this case, I want to use isoparms. Let's use this. Sorry, it's a trim edge. There we go. And now it's ready to build. We'll do it based on a Y vector, and let's make it a pretty good size so that we can see it. This maybe answers the question, how long is that going to be? And so I'm using the slider here to define the length. I could put in a value, or I could interact directly with this to change the draft angle. And so now as I do a recalc, it's going to build that all out to a length of 80 with this draft. I'll change the draft a little bit just to try it. And that entire flange across these two surfaces that have curvature continuity have been built with an 80 millimeter length. I hope that answers the question.
All right. Well, I hope so. I hope so too, Paul. Well, moving on to the next question that's come in. How do you control the radius of the hem flange?
Okay. Let's create a little. Let's go back to that example on the doors, and we'll delete that since we don't need it anymore, and get back to our doors. And we'll just do this quickly again so that I can do a project in the Y direction, these surfaces, these curves, and then we'll do the panel gap on here, and I'll show you how the radius can be changed. So we're going to use the panel gap. And again, this is a single set of surfaces, one curve on surface defining all of that. And let's see, since we've got parting line defined here, let's make this a sweep angle. Just to make it easier, sweep angle is based on the normal off the surface. And once we get that, we'll make some changes in the radius. Again, it's a little easier to see if I put some cross sections on in the Z direction. And we'll just zoom up here on one of them. And we'll turn off the model just to make it a little bit clearer. Now we're just looking at the cross sections. So let's change one to a 10 millimeter and get it to build. Still going to keep a 2 millimeter radius here. And then we'll change the flange, and actually it's kind of neat to play with this. Then we'll change the flange and the angle. Okay, now we got a 10 millimeter radius, and let's also change the sweep angle on the to make it a little bit less, and we'll increase the length. No matter what I do, I'm always going to get that gap in between there. It's looking for the minimum distance in between there. So now I've changed the radius size, the flange, and the angle of the flange, and then we'll do an evaluation to see what the gap is in between them. There we go. Okay, and larger radius, smaller radius. But let's do an evaluation just to see how much we vary. So we went from 5.059 up to our minimum distance here. I think it's recalculating. There we go. Of 4.926. So again, accuracy very close. What you're looking at in the background here, and I'll turn the model on, are all the individual distance evaluations between the two surfaces. Hopefully that answered your question. Another, Eric?
Yeah, we've got a few more actually, quite a lot streaming in at the moment.
Excellent.
One is coming from David Bentley, who says, do you imagine there will be more tools in the future that are task-oriented like the multi-trim function? I'm thinking like a curvature-based round tool or the solid modeling intersection trim round as one fancy tool.
Yeah, you know, we're really looking at efficiencies, and that's one of the reasons that we put the panel gap in. We're looking at other sort of combined workflows that are going to try and strip out some of the drudgery of building up a resultant set of surfaces. So that's the direction we're headed, and we're interested in hearing more from you. So actually, if, suggestions like that, a good idea to go to the wiki page and make your comments. But yeah, I think you're picking up on the right direction, Dave.
All right, next question coming from Jamie, who has not only praised you on your presentation, but asked, you talked about identifying U and V direction. How important is it to maintain unified UV across surfaces in a conceptual modeling environment?
Okay, so let me see if I understand the question correctly, and I'll go back to my example here for the this body side. How important is it for U and V? So if we're talking about the proportional modification, it really doesn't matter whether it's U or V. I'm going to clear those cross sections out, go back to this extend. So as I did this extension here and did this extension over here, it doesn't matter whether these are going in the U direction or V direction when you use that proportional modification on them. So here I'm going to go to the prop mod and select this is my primary. If this had been flipped between U or V, it wouldn't make any difference as far as being able to extend the proportional modification. I hope I'm reading into the question correctly, because I know some people have asked in the past, well, if this is going in the V direction and that's going in the U direction, are they going to be able to? Yeah, you'll be able to still continue to make your modifications across the boundaries. Hopefully that got that one.
I'm assuming Jamie will chime in again if you missed the mark on that. But
yes, please. Yeah, and thanks for the.
He says it's perfect, so he's happy. Thanks for that, Paul.
Okay.
So moving on to the next question, which is a more general question. I'm not sure. I'll ask it anyway. From Christian, what is the easiest way to transfer my user settings and general setup between my university account and my own PC, both of which running 2012 educational Alias?
I've got the best method, I think, would be to go in and make sure that all your user options, basically complete a working session that you're comfortable in, and all of your user options have been stored, like user options, save options. This is going to save all the options that are in all of your control windows, either in the palette or in the control window over here. Make sure that's done. And then underneath the preferences, you want to do save the preference set. And so what this is going to do is Christian prefs. Once you've done that, you've saved everything that can be possibly made unique about your setup, and now subsequently you can load that preference set. So save that off, and then there's Christian's prefs. Take that with you. It's essentially a zip file. Consider it as a package of all your options. Save that, put it onto a disk, mail it to yourself, and then come back into your preference sets, which are inside of your user application data. This is Windows 7, so roaming, Autodesk Alias, the release that you're working in, and it's inside the preference sets. And that is just one great big bowl of preferences and options that you've been using. Eric?
Yes, Paul, I'm here. Great, well, thanks for that. I've got a few more questions here. Do surfaces have to be tangent continuous to select for proportional modification?
They don't. In fact, let's do a little example here. Let's do a transform on this, and I don't want prop mod in this case, or I guess I could actually. Let's pick this control. Let's pick go back 2 rows so that we're going to destroy the excuse me. We're going to destroy the tangency. We'll go up to this row and down there. So now let's do a modification on that. You know, one thing I should point out too, excuse me, I've just set it so that they're both going fall off of 1. Let me put that back and instead I don't want it to make any changes in one direction. Let me just put this to 0 here, break the chain. Wrong direction. Let's make it this way. Now you'll see that I'm making a proportional modification, and it's only having an effect in one direction. In fact, you can see how the tangent break is happening here. And then let's go and see if we can do a proportional modification on all 3 surfaces. Yeah, pick those, transform, select this, and let's select this. There you go. Eric?
Okay, well, thank you for that.
Yeah.
Yes. Another question that we've had come in is, can additional environments be added to the scene?
Yes. So this is the case where you're using and I'm using my visual states down there, and I've stored one. Let me bring it back. This is what's called the dock area. There are 3 additional geometric environments that are supplied with Alias, but you can find some really interesting ones out on the web. And I guess I would mention, just to make it clear how you can do it, if you go to the wiki help and you go to the What's New in Alias 2012, you will see one here for 3D geometric environments. And Carrie Kingston did this. She did all these What's New videos. This one will give you all the information you need in order to see how you can swap in different geometric environments that then get mapped, and I'll pull back the veil here a little bit. I'll get mapped to a piece of geometry. In this case, it's a cylinder. You can also map it to a sphere. They both show, it depends on what the image light is like that you're using, but yes, you can use different geometric environments.
Perfect. Another question from Diana. Can a panel gap be created with a center line as well as a primary line?
Not currently. Currently we use the primary line as the means to identify which side you're going to be building the gap on. We have gotten a lot of feedback that people would like to be able to do it with a center line. So we're working on that now for a subsequent release.
Okay. And will the draft manipulator be moved to the multi-surface draft?
Will the draft, I see. Yeah, there's been some discussions of this on several forums. Just to put it in the context of what we're talking about, we always are trying to consolidate the number of tools that we have. We have an older draft flange tool over here, and when I make a selection, it actually puts a manipulator. Let's try it. And it brings up this manipulator. That's not included in the MS draft, but we have gotten lots of feedback that it's very useful for people's workflow. So we haven't done it in the 2012 release, but it is something that we recognize people appreciate the use of that manipulator. So we're going to try and find a way to integrate that into the MS draft tool in the future.
Good. Final question that I think coming from us would be, are fillets G2 continuous on panel gap?
Not in the 2012 release. They're just G1 or tangent continuous. So we recognize, again, people have told us that it's fairly important that we make sure that we can get them G2 as well. And so that's a focus for our current development cycle, and hopefully we'll be seeing it in the near future. So center line and the ability to do G2 fillets are recognized as important to customers now that they've seen the panel gap.
Okay. Well, thanks again, Paul. You're getting a lot of praise here from the audience. Thanks, Paul. Great to hear from you. Fantastic release. Very nice presentation, etc. So,
excellent.
Thank you very much, Paul. I mean, obviously, there's many improvements in the newest version of Alias that you've outlined: the efficiencies, the combined workflows, curves manipulation for input, and trimming corners, and across multiple surfaces. So, as well as the MS Draft for many different type-saving features. So, I do want to thank you for doing this presentation for us, and I want to thank everyone as well in the audience for joining us today.
Thank you,
I
Eric.
hope that, my pleasure. I hope that all of you in attendance will be able to check out the WikiHelp page that Paul spoke about at the start of his webinar and that he mentioned as well here towards the end, where you'll be able to find out more about Autodesk products that haven't been covered today, and indeed more about the 2012 improvements. So thank you again, and today's webinar will be uploaded into our archives and accessible in the future, as I've mentioned. So all of your colleagues who've been unable to attend the live presentation can indeed view it in the future. You can access it and indeed any other previous webinar under the Process tab on the Car Design News homepage. So thank you again, Paul, and thanks again for joining us today, and I hope you'll join us again in the future for our next webinar. Thanks again, Paul.
Thank you, Eric, and thanks everybody for attending.
Goodbye.